Question 3. Okay, this question is about chlorine and related reaction. Okay, so chlorine reacts with silicon to form the SiCl4. So this one is the one molecule of SiCl4, and this is the simple molecular, just one molecule, no network. And describe the appearance of the SiCl4 at room temperature and pressure. Okay, state is structure and bonding. So it's quite easy. Appearance is liquid. SiCl4, remember, okay, is liquid. PCl5 is solid. Okay, SiCl4 is a liquid. You can say that is colorless or yellow liquid, both acceptable. Structure and bonding. Structure is simple molecular because one molecule is just one Si4Cl. So it's a simple molecular structure. And the bonding, remember, bonding is the Si and Cl. The bonding is covalent bond. Covalent bond. Okay, for part B, sample of magnesium chloride and phosphorus 5 chloride, PCl5, added to separate beakers of cold water. So now, fill in this part, okay, for the magnesium chloride and PCl5. Okay, at room temperature, magnesium chloride is a white solid. PCl5 also a white solid. You can say that is pale yellow solid. Both they are solid. Okay, one similarity in observation on adding cold water. Okay, so when magnesium chloride dissolve in water, so it's form clear solution. Same as the PCl5. Magnesium chloride when dissolved in water form these ions, and of course is colorless. PCl5 when it dissolved in water, it will form HCl gas and the phosphoric acid. Phosphoric acid is clear, no color. So that's why these two chloride compound, after they dissolve or reacts in water, it will form a colorless solution. Okay, one difference in observation on adding to cold water. So we know that PCl5 will has the steamy fumes, HCl. Magnesium chloride is just dissolved, nothing other than that. So no steamy fumes. Okay, this one there is a steamy fumes form. The pH of the solution for the sodium chloride is 7. Magnesium chloride is slightly lower, is 6.5. It's better you put 6.5. Right, but the range that allowed is 6.5 to 7. In the mark scheme, when they mention 6.5 to 7, it not really means that in exam you follow them. You can just give a value between this range. So means 6.5 also acceptable, 6.6 also acceptable, and so on. The pH of this final solution, phosphorus 5 oxide, 5 chloride, when dissolved in water, because it's from HCl, and this phosphoric acid, they are strong acid, so it can be pH 1 or pH 2. The range that allowed is 0 to 4. Okay, normally we will put pH 1 or pH 2. Right, so each one row, each one mark. Right. Okay, the C part 1. State the reagent and condition required for the formations of sodium chlorate. So sodium chlorate 5. So means the oxidation number of chlorine is positive 5. So to form this, we know that must use hot NaOH solution. If cold, then it just form NaClO. Okay, part 2. Explain why the reactions in the C part 1 is described as disproportionation reaction. Very easy. You must always explain using oxidation number. So you need to mention the change in the oxidation number. Okay, initial oxidation number is 0. So oxidation number of chlorine decreased from 0 to -1. Okay, this is first. So second, and increase from 0 to +5. So another pair. Okay, again, oxidation number of chlorine decrease from 0 to -1. So it's a reduction. From 0 to +5 is oxidation. So oxidation and reduction is happen simultaneously. Okay, and for the same elements, in this case is chlorine, so this we call disproportionation. Okay, part D. Chlorine reacts with methane in a series of reactions to produce chloroalkane. So this one is a free radical substitution. Okay, state the conditions required for the chlorine react with methane, the hydrocarbon. So it must have UV light. UV light is used to break the chlorine bonding. So it will break homolytically from two radicals like this. And this chlorine radical will approach the hydrocarbon and it will induce another radicals formation. Right, so we'll discuss this one later. Okay, part 2. One of the products of the reaction is CH2Cl2. This product, okay, which reacts further to form CHCl3, means one of the hydrogens here is being substituted by the chlorine. Complete this table 3.2 to show details of the mechanisms that form CHCl3 from CH2Cl2. Okay, so first, initiation, very easy. Chlorine molecules undergo homolytic fission, form two chlorine radicals. Remember, put a dot beside the chlorine. Okay, propagation. This one is, okay, the chlorine radical will approach this CH2Cl2 just like this. Okay, approach this. So the one of the CH bond will break homolytically. Here, one electrons will move to hydrogen, another electrons will move to carbon, okay, to form these two species, this radical and this radical. The hydrogen radicals will combine with the chlorine radical and form HCl. So this is the new radicals that, okay, produced. Okay, so means is this one, CHCl2. CHCl2. It's actually better to put the dot beside the carbon, because the carbon, okay, is with the radical, with the unpaired electron. Okay, and HCl, okay, I already explained just now. This is a propagation, means a radical form another radical. Termination is very easy, because it's just one to form this product, CHCl3. So we just use this radical that form in propagation, reacts with the chlorine radical. So these two will form bonding and form CHCl3. So means the last step, termination step, you need to use these two radicals, chlorine radical and the CHCl2. Part E. CHCl3 and HF used to form CHClF2 in a substitution reaction. Construct an equation for this. This is very easy. So you just need to put the reactants, which is CHCl3 and HF. Okay, and the chlorine is the one that gets substituted now. So it will form CHClF2, and the H in the HF, this H will combine with the chlorines that being substituted and form HCl. So it will form 2 HCl because 2 chlorine removed, or 2 chlorine being substituted. Okay, part F, this is the MS question. X is a product of a substitution that occur when CHClF2 reacts with bromine. Okay, fluorine is just one isotope, fluorine 19. The mass spectrum of X showing molecular ion at 164, 166, 168. This one telling us that 164 is M, 166 is M plus 2, and this is M plus 4, extra 4 mass unit. So just fill up the table with the correct formula of the molecular ion. Because this one is the lowest mass, we know that, okay, in this molecule, okay, first before we discuss this, this is a reaction. It's better to let you know, okay, how it works. So from the question, we know that the hydrogen is being substituted by bromine. So now, in the compound, it just has the C with 2 F, 1 bromine, 1 chlorine. After reaction, it will form this molecule. Okay, as is mentioned in the question, substitution. And if these products form, we know that 1 bromine and 1 chlorine in the compound, the bromine can be bromine 79 or bromine 81. Chlorine can be chlorine 35 or chlorine 37. So means it is going to have different combination. 164 is lowest mass among this. Means the chlorine and bromine, they must be the lower mass isotope. So it's going to be CF2 chlorine 35 and bromine 79. So this one will give M over E 164. If it's 166, it's telling us either one of the isotope is heavier. Okay, let's say it's CF2 Cl37, chlorine 37 with bromine 79. Or it can be chlorine 35 with the bromine 81, the heavier one. So these two will give the M over E 166. Of course, the examples already given here, the M plus 4, so you no need to worry. So it's the both heavier isotope, okay, 37, 81, so which will give 168. What you need to solve is just M plus 2. Okay, that's all for this question. Thank you.